And continuing with my series on limits here, I'm calling it Boot Camp on Limits. This is video 2, which is about one-sided limits. This should be a pretty short video, I think, so hopefully you'll find this helpful. Here's what we're talking about in this boot camp. Last time I did what is a limit. Today we're going to talk about one-sided limits, and I sort of hinted at them in that last video, so we're going to formalize it today in this video. But there's all kinds of other topics. I'll be doing separate videos for all of these, and I'll be putting it in a playlist. I will link it down in the description, so be sure to check that out. Okay, so remember last time we talked about the fact that limits can fail to exist. And remember, limits are all about what you're approaching, not what you actually arrive at once you get there. It's all about what you're approaching. So for example, the limit as x approaches 5. So over here, here's 5. As we approached 5, do you remember what we were approaching? Answers to limits are y values. So this would be 0. So these are y values always. Okay, so answers to limits are outputs. As x approaches 0, what is the function approaching from a y perspective? So as x approaches 0, do you remember we said that coming from the right side here was different than the left? So it kind of depends which side you're on, right? That's what we're going to really formalize today. So this was the one that did not exist. What about -2? Well, same thing there. You see that coming from the left and coming from the right, we've got different y values that we're approaching, so therefore it doesn't exist there. That's okay. We're going to have a way to sort of deal with this in a moment. What about as x approaches -5? Here's -5. As we approach -5, remember it doesn't matter that this is an open circle. It doesn't matter where you are when you arrive. Limits are all about what you are approaching, where you think you'll be. It sure looks like we're approaching 2 as we get there, and indeed we are at 2 once we get there. So this answer would be 2. So what about these one-sided limits? Well, they're called limits from the left, or left-sided limits, or limits from the right. And we saw some. Let's use this one right here. We saw some, I'll change the color so it stands out a little bit for you, at x equals -2. So the limit as x approaches -2, now here's what we do. Ready? If you're coming from the left, you put a little minus sign up here to say we're coming from the left, from the negatives. So when we're coming from the left, the limit on this graph, what was it? It's 2. You see how coming from this direction, it sure looks like, let me get rid of this circle, it's kind of in the way now. It sure looks like we are approaching 2 as we come from the left. So this is not does not exist. It is the value 2. Now coming from the right, what do you think we do? The limit as x approaches -2 from the right. So that would be, here's -2. We are going to approach from the right, so this direction. That's from the positive end of the number line, right? Positive numbers are up here. So we put a little plus sign here. That's called approaching -2 from the right, f of x. The answer is 0, because this was heading toward 0. Y equals 0 as we were moving that way. So the notation here is limit as x approaches a from the left on a function is a number. That's called the limit from the left, or the limit as x approaches a from the right f of x is a number. We call it that right-handed limit, right-sided limit, right-hand limit. So we can discuss limits here, but they can only be one-sided, because remember the limit there did not exist. The plain old limit did not exist. It was right here. The plain old limit did not exist because the left did not equal the right. Because the left did not equal the right, these two are not equal, so therefore the limit there did not exist. And I'm going to formalize that here in a second. So let's look at another drawing. You're welcome to pause the video here and see if you can come up with the answers. So from the left, as we approach 0, that's what this says, from the left with the little minus sign here, that's from the left. As we approach from the left, it looks like it's approaching 1. So as we travel this way, this is from the left. Now, as we approach from the other direction, I'll change color so that stands out for you. This would be coming from the right as we approach 0. That's also approaching 1, so they're the same. What is the limit at 0? Well, since the left and right equal, remember we talked about this last time, there's no jump there, they are, the limit does exist, and the answer is 1. So the limit at 0 is 1. So if the left and right limit exists and they are equal, then the limit at a exists, whatever a is. So let's actually write that down. You ready? If the limit as x approaches a from the left equals the limit as x approaches a from the right, then the limit as x approaches a exists. So all of these would be L. They'd all be the same number. L. All right, so if the left equals the right, the limit exists there. Even if there's an open circle. I did that on purpose. Even if there's an open circle, don't be confused by that, because limits are all about what you're approaching. Can't say that enough. And you're thinking, well, yeah, he says it a lot. Okay, we've got a lot on this page. So what I want you to do is pause the video and see if you can do what I have here. I have 12 questions lined up for you. All right, on this crazy graph. And then this is it for today. This is the one-sided limit concept. All right, so let's check your answers now. This first one says, as we approach -3 from all the different ways. So here's -3 right here. As we come, let me get rid of all those. As we come from the left, like this, it looks like we're approaching -1. As we come from the right, it sure looks like it's the same thing. So therefore, since the left equals the right, the limit exists there, it's -1. Now what about f of -3? What does that notation mean? That's just asking you to go to the t-chart and ask yourself what y corresponds to x equals -3. And that's way the heck up here, folks. So this is +1. The limit still exists there. Doesn't really matter. It's just a reality. And I wanted to review the whole notation thing here. All right, the next series, as we approach -1 from the left. From the left would be this direction right here. It sure looks like we're approaching -2. So let's write that down. Now what about from the right? As we approach -1 from the right, see, this is one where it's different. We get 2 this time. So they're different. So this would be does not exist, since the left does not equal the right. Now what about f of -1? Does that exist? Yes, it does. There's a closed circle right here. This is at the point -1, -2. So this would be -2. All right, finally, what about the situation there on the right? I didn't do anything here on this problem. We are looking over here at 5. How about 5 from the left? That's 2. How about 5 from the right? That's also 2. What is the limit? 2. What is the function there? I don't see a closed circle anywhere, not there or anything. I don't think the function even exists there. There's a little hole in the graph. So this would be does not exist right there. It means it does not exist right there. All right, so today we went over how to do one-sided limits. I hope that you found that pretty easy. It's a nice little way to describe what a function is doing just from one direction and not both of them. So that can be really useful in math often if we just want to describe what's going on from one direction. All right, so hopefully you'll keep it along here following my boot camp, and hopefully it'll be helpful so that you'll ace that test. All right, until next time.